I've got to account for forces. I will say this is my 200. And I'm going to use Paregnon's theorem, which says break this sucker into components. One here, one there. This is going to be 200 sine 55. That's 200 cosine 55. Over here I have another one, 300. I'm going to break that up into an x and a y. That's going to be 300 cosine 30, 300 sine 30. This one's already, I don't have to break that up, it's in the y. And then I have a moment, 400. Here is point A. I'm going to sum moments at A, and I'm going to take clockwise positive. Can I do that? Rebel. What's the positive standard? Counterclockwise. Why? It obeys the right-hand rule, right? So what do I do? This is the first time we've seen it. What do I do with a moment? A moment is a moment. You don't have to multiply anything by it. You just dump it in. It's clockwise, 400. It's in the same direction as positive, so I'm going to put a positive on it. If it was going counterclockwise, I'd put a negative on it. True or false? Here's how I get my true falses. True or false? Moments are free vectors. Moments are free vectors. Oh, that's an interesting one. Moments are free vectors. If you had to choose true or false, how many would say true? 1, 2, 3, 4, 5. Only 5. 6, 7. How many would say false? How many really sitting there going, what the fuck is he talking about? I don't know. How many don't know? It's okay not to know right now. It's not so good when you're taking a test. The answer is, it is a free vector. Remember we had bound or fixed. Give me a vector that's bound or fixed that we've already talked about. Bound or fixed. Oh, goodness gracious. Bound or fixed. Give me a vector that we have. What? Position vector. Go back to the definition of position vector. A fixed vector that locates one point relative to another. That is a fixed. What about a sliding? Sliding, because there's 3 of them. Fixed. Example, position, sliding. Force, by the principle of transmissibility, I can slide it anywhere I want along its line of action. And now free moment. Alright, next. This guy's creating no moment through A. Why? Because its line of action goes through A. There is no D. Next, I've got 300 sine 30. That's the force. I need a distance, perpendicular distance from here to here, and that would be 7 plus 5, 12. I need to put a sign on it. I need to put a sign on it. Let's see. I'm going to move this sucker along its line of action down to here like so. That would be the principle of transmissibility. I now go around A in a natural order. What is this? That's counterclockwise. Negative. Think of it as, here's my index finger here is A. I'm pushing here like this. That is counterclockwise. 200 sine 55. There's the force. Times the distance. Well, Here's its line of action. What I really need is that perpendicular distance D. What is that D? 6, positive or negative? Well, if I bring it to here by principal trans and then slide it over, what is this? That is clockwise. Positive. Then I have 200 cosine 55. There's the force. I need a distance. What's its distance? Well, here it is right here. I'm going to slide it up to here. And now the distance would be that distance right, which is also 12. Positive or negative? If I follow the arrow around, what is this? Yeah, that's negative. That's got to equal to the moment that's being generated at A, which is 1093.66 pounds, feet, and it is, oh, it's a negative. Or moment A is 1093.66 counterclockwise. Because I got a negative 1093.
What about the 100?
What 100?
100 pounds.
Oh, we forgot that one, didn't we? Let's do that. The answer's still the same. It's still that. Let's put the 100. 100, there's the force. Thanks for reminding me. Distance. Distance from here to here is 7. And that's going around A in a clockwise fashion plus. Thanks. And there you have it. The answer is still 1093. Okay? Who's not with me? I figured I'd hit the moment stuff again because it should be fresh in your mind from Wednesday and Thursday. So I wanted to hit one more so that if you happen to be going to chapter 4, you have a few more things to go by when you're doing moments. Okay? Any questions on how to do a moment? You know it's coming. Question number 2 is going to have some sort of bar, some sort that you're going to have to take a moment on. It's coming. It's not a maybe, I wonder if, no, I'm telling you, it's there. I'm already creating the test. Already created question number 1, I'm working on number 2 right now. When I say create, it's a sketch. It's not official. Because I usually sketch it out, put it down on paper, and then I let it go. I let it stew for a little bit, then I come back to it, and I finalize it. Any questions on this? We're good? Okay. Because I can put it wherever I want. There, it doesn't require a distance. It's already a moment. So, yeah, I put it here, but I could go over here and put it there. Immaterial. M is M. There's no D that's associated with it. Now, you can try this one for yourself. That's also in the papers in the homework, not homework, the help session. I'll give you the answer to this. Net moment at A is 1.9 Newton meter clockwise. I'll give you the answer. And if you can't do it, we can certainly do it next week in the help session. Or if you need to see it earlier than that, I can show it to you if you come to my office. It's counter. Did I say clockwise? It's Friday. It's time for a week. Yes, it's counterclockwise. I wrote it right, said it wrong. Okay? You with? Alright. Let's move on. I told you we would do this problem, which is an old test question. Hopefully you tried it, because I gave you the answers. If you didn't, that's on you. But I'm going to look at this and say, let's do this because it's a test type question. The first thing I notice right away in the words, equilibrium. But the first thing I notice in the diagram is what? What's the first thing you notice? Hey, there is a point of concurrency. The point of concurrency happens to be that ring O. All the forces are coming to it. If I'm looking at equilibrium, how many equations do I have? 2. Some force X, some force Y in 2D. Which means I can only solve for 2 things. That's it. I can't solve for 4 or 5 or 6 things. How many things are coming into the ring? Well, I got one cable coming off, which I labeled T, from the pulley system. Then I got that K1, K2 series spring, that's 2. I got the weight, that's 3. And then I can take all that bullshit up there and replace it into one spring. That's 4. There are 4 things coming into A. I can only solve for 2. I gotta come up with 2 numbers, 2 values, in order for me to solve for the other 2. The easiest value to get is the pulley system. That gives you usually a value because I see all the weights. So I'm going to come in and I'm going to say, hey, this is 120. That has to be 120. Well, if that's 120, what are these guys? 60 apiece. Right? If I call this T, that's T, that's T, that's T, that's T, that's 2T. So far, so good? All right, let's isolate that 90 pounds. Free body diagram on that 90 pounds is I have a 90, I have a 60, I have a T, and I have a 2T. There's the free body diagram. Again, free body diagram is anything you want to be, but it's nothing more than, hey, can you account for things that are occurring on this diagram? Well, I just did. I accounted for the forces appearing on the diagram. Now I'm going to say some forces in the Y equals 0, positive up, 2T plus T minus 90 minus 60 equals 0. What is T equal to? 50 pounds. So now I know this is 50. As far as I'm concerned, that is history in my mind. I don't care what the pulley system looks like anymore. It doesn't matter. What I wanted was that 50 coming in. That's it. Right? So that gives me 1 out of 3. I need 1 more in order for me to be successful. Well, if you look real closely, it says that spring 1 is deformed 0.02, spring 2 is deformed 0.11. Can I get an equivalent spring? Yeah. So I'm going to say 1 over K equivalent. 1, 2 is 1 over K1 plus 1 over K2. That's 1 over. K1 is 1200 plus 1 over K2 is 1800. K equivalent is equal to 720 pounds per foot. X equivalent is x1 plus x2. That is 0.02 plus 0.11, giving me 0.13. Therefore, the force in spring 1, 2 is 720 times 0.13. That's gonna give me 93.6 pounds. Remember, I needed two values. I just got the two values. Now I can draw a free body diagram, put the two values in, and say I don't know W, the weight, and this set of springs in series and parallel, so it can be reduced down to one spring. Can I not? Yeah. So here is my free body diagram, which says here's A. I got a weight. I got 50 pounds. I got 93.6. I got some spring force, which replaces the 4 springs to the left of the ring. Now put in your coordinate system. Well, hell, they only use one. YX. And put in my angles. This angle is 25 degrees. Now I'm going to say some forces in the Y equal 0 positive up. That says 93.6 sine 25 minus WB. This is WB, but just W is fine. Equals 0. WB is equal to 39.56 pounds. Some forces in the X equals 0 positive to the right. That says 50 minus FSP plus 93.6 cosine 25 equals 0. FSP comes out 134.83 pounds. Nice. Now I can't find an equivalent spring for all those springs to the left of A. I can sit there and say, hey, K equivalent 4, 5, 6 is K4 plus K5 plus K6. That's equal to 1,000 plus 1,500 plus 500. That's equal to 3,000 pounds per foot. Take that now as in series with K3. So 1 over K equivalent 4, 5, 6, 3. That's 1 over K 4, 5, 6 plus 1 over K3. That's 1 over 3,000 plus 1 over 4,500. That tells me K equivalent is equal to 1,800 pounds per foot. Yeah? Now think about this. What you just did here was you said, hey, this is in series with this spring. This spring here is K3. That's 4,500. This is the 3,000. I made the equivalency that this is one spring with the value of 1,800. Correct? You now know the force in the spring. That is 134.83 is equal to 1,800 times X. You can find the X if you needed to. Oh, you can't see it. I didn't ask for it, I just threw that in, just to let you know that you can find the equivalent distance for the springs. What else do you know? What else do you know? Well, you know these springs, these three springs, right? They have the same deformation, but their forces are additive. So it's force 4, force 5, force 6 for these guys. Yes? Who's not with? How many tried this problem? Did you get what you got, what I got?
Yep.
Perfect. Awesome. Did you attack the set problem the way I did? Now you're starting to think like an engineer. Okay? Now you're starting to think like an engineer. Before you were thinking like high schoolers. Now we're getting to you. Any questions on this one?
Okay.
Remember, it was an old test question too, very similar to what we did in the Pro Copy booklet. Now, if once you get comfortable with moments, there's a problem in here in the help session problems that looks like this. We will do this problem sometime before you take the test. But notice it says 2 on it. It's a question number 2 on an old test question. I am not hiding anything from you. I am telling you what I'm going to do to you. Okay? It is in your help set. You don't need to take a picture. You can just download it. Go to the front page of Canvas, go down to the bottom, it says help session problems. It's there. Okay? The reason I need you to do this is because it's even more similar to a question number 2, because if you look real closely, if the magnitude of the moment about point D, which sits over here, is 1720 pounds-feet clockwise, find me these things. Find me ABC. But don't do this until you are comfortable with finding moments. Don't do problems, question number 2 on the test, in the testing manual, until you are comfortable doing moments. Because most of them are going to say, hey, the moment at this point is 0, the moment at this point is 1720. Okay? This one I like because you guys are instant gratification people, and this one does not give you instant gratification. You always want that thumbs up. You ain't getting a thumbs up on this one. Okay? The reason is, you write your first equation, you'll look at it and go, fuck, I have too many unknowns. What the hell do I do now? Let me write another equation. Shit, I just generated more unknowns. So it's not an instant gratification. I write a moment, I get an answer. You don't get that here. I wrote it specifically for your generation. Because your generation wants instant gratification. You don't get it in this problem. You're going to have to set up, in essence, what it boils down to is setting up 3 equations and 3 unknowns down the road. So that's the problem with this problem. And what am I doing? I'm playing on you wanting that instant hit of, I got an answer. You didn't get an answer when you wrote the moment equation. Why don't you get an answer? Well, because there's 2 unknowns, cable A and cable C. Unknowns. That's 2 unknowns. That means when you write the moment equation, you're going to get 2 unknowns. You don't get an answer. Shit. Well, that sucks. Yep. You don't get the dopamine hit right away. Right? So you then write another equation. Ah, shit, I generated another unknown. Now I got 3 fucking unknowns. So you're going to have to write 3 equations, no solutions, with three unknowns, and then you solve the three equations together to get your values. That's the whole, if you want, trick behind this problem. It's awesome. Because it delays your gratification. Something you're not used to. Well, most of you aren't. Anyway, don't do this problem until you are comfortable with moments. Okay? We will do the problem together, but don't do it just yet, because we just started covering moments. Next problem. Let's do a 3D problem. 3D problem. All right. What do I have? 3D. Y, Z, X. First thing I look for. Is this similar coordinate system? Yes. Is it right-handed? Yes. Right? Next, it's a 3D problem. The first thing that pops in my mind is check the coordinate system, dipshit. Yes, I call myself dipshit sometimes. Because sometimes I do dipshit things. Next, what's the next thing I see? Hey, how did Nora give me this information? Did he give me alpha, beta, gamma? Nope. Did he give me a double projection problem? Nope. Did he give me a bunch of distances? Yes. Instantly my mind says, 5-step process, gotta do it. And the reason I'm doing this right now is because you are going to get a quiz that has dimensions in it, which means you gotta go through the 5-step process. So I might as well review it so you get a good grade rather than a 50. Hopefully. Okay? All right, so what does it say? Notice I haven't even read the damn question and the things that have popped in my head just from looking at the diagram. Right? I haven't even read the question. But I know the coordinate system is Hibbler's. I know I got to go through the 5-step process because I don't see alpha, beta, gamma, I don't see double projection, I see a bunch of distance. So already I'm starting to map out my solution to the problem. I haven't even read the question yet. All right, so the system's shown because the question could be, hey, find me the resultant of the two cables. Or it could be, hey, find me the cables if we have equilibrium. So I don't know which one it is until I read the question. So the system shown consists of a derrick OA and two cables AC and AB used to support a 2,000-pound load, which is held, and here's the magical word, equilibrium. Once I see that, what goes in your head? Yes, sum of the force in the x equals 0, sum of the force in the y equals 0, sum of the force z equals 0. How many things are in there? 3. Cable AC, 1. Cable AB, 2. And the derrick OA, 3. How many equations do I have? 3. Right? I have 3 unknowns, and I have 3 equations to work with to get the solution to those 3 unknowns. Perfect. I don't need to go grab something else from someplace else. Pretty straightforward problem. Find me A, the force in the derrick, tension in the cables AC and AB. The 3 unknowns that we just talked about. All right, 5-step process. What's the first step in the 5-step process? Oh my. What is the first step? Hey, find me these damn coordinates. 0, of course, is 0, 0, 0. A happens to be 0, 12, 10. B happens to be 4, 0, 12. C happens to be -4, 0, 12. What am I doing here? I'm doing a free body diagram that looks like this. Here's the point of concurrency, A. I'm going to show a force this way, FAC. I'm going to show a force that way, FAB. Then I'm going to show a weight downward 2,000. And I'm going to show a force FOA. Notice FOA, I drew in compression, pushing up against. Now, again, these are all guesses. It could be that OA, which is a solid member, not a cable, could be pulling. But I drew it in compression. Pushing up. If I'm right, what will I get at the end? A positive number, which means you're a genius. Right? No, I just guessed right. So, 5-step process, that's step 1. Step 2 says find me RAC. That's XC minus XAI plus YC minus YAJ plus ZC minus ZAK. RAC is, C is -4. -4 minus 0, that's a -4I. 0 minus 12, that's a minus 12J. 12 minus 10 plus a 2K. Instantly calculate step 3, which is magnitude of RAC. Square, 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 add them together, take the square root. 12.806. Remember, I try to keep 3 decimal places minimum when I do a 3D problem. Doesn't matter what chapter I'm in, 3D, I try to keep 3 decimals. Therefore, FAC vector is FAC magnitude times minus 4I minus 12J plus 2K. Divide this by 12.806. This is the unit vector. There's the magnitude. So what I did here is step 4 and 5 combined. This is going to give me minus 0.312 FACI minus 0.937 FACJ plus 0.156 FACK. There's FAC in terms of IJK.
Thank
How many times do I have to do this? 2 more times, right? 2 more times. I gotta do now AB. RAB is XB minus XAI plus YB minus YAJ plus ZB minus ZAK. Please note, I've been doing this a hell of a lot longer than you've probably been alive, and I still write the position vector equation out. Now I sit there and say RAB is, well, I need to find B and A. 4 minus 0, 4I. 0 minus 12, minus 12J. 12 minus 10, plus 2K. Magnitude of RAB, obviously the same, 12.806. So FAC vector is magnitude FAC times the unit vector 4I minus 12J plus 2K. Divide this by 12.806. What's the difference? The difference is the minus signs. That's going to be a positive 0.312 FACI minus 0.937 FACJ. Ah, shit, AB. My bad. See, I told you it's Friday. AB. plus 0.156 FAB K. There is FAB. Any problems? Yeah.
Is the middle one supposed to be positive and the K supposed to be negative? Because my FAC has negative J and positive K. Or,
No. These are positive here, negative there, negative, positive. You're saying AB, 0 minus 12 is negative 12. 12 minus 10 is a positive 2. I'm right. You're wrong. ROA vector is XA minus XOI plus YA minus YOJ plus ZA minus ZOK. ROA vector is 0I, notice I have a placeholder, plus 12J, plus 10K, magnitude of this, square, square, I'm gonna take the square root, 15.620. FOA vector is FOA magnitude times the unit vector, which is this, divided by 15.620. That gives me 0 FOA I, notice placeholder, plus 0.768 FOAJ, plus 0.640 FOAK. I now have FOA. Again, I'm doing it, please do it. Put the placeholder in. If you don't, what's going to happen is you're going to think the first term, 0.768, is the I. It's just a mental thing. It's like they do you badly when they give you the, hey, this only costs $3.99. And your mind says, oh, it's only $300. No, it's $400. It's $1 off $400. Same thing here. Your mind's going to play tricks on you when you don't put that 0 FOAI. You're going to think, oh, 0.768, that's the I. Okay? I need you to pay attention to details. Because that's going to be your saving grace outside the real world. You must pay attention to details. And please, please take pride in your work. If you don't take pride in your work, why are you doing it? Why are you doing it? I take great pride in my work. If you haven't figured that out yet. I take such great pride that I do new tests every single semester. I have 30 years of old tests sitting in cabinets. I could easily be, let me pull one out. I don't. Why? Because I take pride in what I do. I try to be the best I can for you. I want you to be the best you can for me. Actually, for yourselves. Have some pride in what you're doing, and not, why the hell are you doing it? What's the purpose? And don't sit there and just say, well, I'm a mechanic, I just need a C+. That's not having pride. That's just barely passing by. Having pride says, I'm going to get a fucking A. And I'm going to do whatever it takes to get that. Shoot for the stars, don't shoot for mediocrity. Whatever you do, I don't care if you're a garbologist. I don't care if you're a plumber. Be the best goddamn plumber you can be. You will become mothers and fathers. Be the best damn mother and father you can be. That's all. Take pride in what you're doing. If you don't, why are you doing it? Which reminded me, I had a former student. Oh, yeah, let me share this with you. Out of the blue, but I took your statics and dynamics courses back in 2022 and wanted to reach out to express my appreciation for the impact you've had on my career. I pursued a mechanical engineering for my first 3 semesters before transitioning to electrical engineering, where I eventually completed my bachelor's degree. Of the many lessons I've carried forward, the one that resonated with me the most was your saying, always take pride in your work. I can't fully explain why, but it rang a bell in my brain when you said it, and it's immensely changed how I have taken on my responsibilities since that. I still remember missing an A in dynamics because I forgot to submit the final 2 homework assignments. I had saved them for after I finished prepping for the final exam, and unfortunately, or perhaps fortunately, the deadline passed. I asked if my situation could be reconsidered, but I'm genuinely glad it wasn't. Instead, you told me to remember this moment and carry it forward because it would help me in the future. You are right. While I may not be the most meticulous person yet, I've made progress, and that lesson has stayed with me. Thank you for being not just a professor, but a mentor and coach. I'm certainly not the only student whose perspective you have shaped, but I want to take a moment to let you know how much it meant to me. Thank you for your time, and take care. Warm regards. This is why I do what I do. You may hate me now, but I know down the road, you're going to sit there and say, you know what? He had an impact on me. That's my goal, to have an impact on you. That's what a teacher's goal is to have an impact. Hopefully a positive, not a negative. So I've been telling these stories for a while. Take pride in your work. You just saw it. He graduated in 2022. 4 years ago. Right? 4 years ago. When I tell you, please pay attention to details. I'm sure I've said that for 30 years. Please. Take pride in your work. I've said it for 30 years. Right now, I'd be like, shut up, old fart. And I never think of myself as an old fart. Even though I do have gray hair. It's okay. I know a friend that's 40 years old who's got gray hair. Like, worse than me. I'm like, what the fuck happened to you? I don't know. Huh? Stress? Maybe genetics, who knows? Hey, what are you doing there, Drury? Trying to finish it. Oh, so you're ignoring me. I see how this is. Where's the love? Let's finish it for Drury because damn, she's like on it. All right, now that I have all of them, sum forces in the X equals 0. Positive coming out of the paper. I'm putting all the I's together. 0, FOA, plus 0.312 FAB, minus 0.312 FAC, must equal 0.
I have a question.
Why?
Why in that specific order?
It doesn't have to be in that specific order. It's immaterial what order you put them in. Positive to the right. All your J's, please. 0.768 FOA. Minus 0.937 FAB. Minus 0.937 FAC equals 0. Why in that order? Because my mind says A, B, C.
Well, the reason I was asking, last night I was trying a calculator method to do the 3 unknowns, and depending on what order I put them in horizontally, the answers would be different.
Order does not matter.
Okay.
some forces in the Z equals, now in a calculator it might matter, I don't know, but it usually doesn't matter. Positive upwards, 0.640 FOA plus 0.156 FAB plus 0.156 FAC must equal to 2,000. Or minus 2,000, the way downward is in the K direction. Minus 2,000 equals 0, or just equal to 2,000. Same thing. What do I have now? Statics is over. Now I have 3 equations and 3 unknowns. Now your math skills kick in, or your calculator skills kick in. FAB will be 1067.42. FAC 1067.42. FOA 2604.63. All of them with a positive sign. That means I'm a genius. I guess the right direction for them in the free body diagram. Genius. Yes, sometimes I go, love myself. Of course you should. If you don't love yourself, who the fuck is going to love you? Questions on this? Yeah.
When I'm putting it in here, I'm getting negatives on it, so these impressions.
But the way we set it up, everything should come out positive.
That's why.
I don't know. I don't do it in a calculator. So figure out, maybe you rearrange them incorrectly or something. I don't know. All right. Any questions there? Yeah. I can't hear you. Realistically, yeah. It's always going to be in tension. Never in compression. Yeah. Sure. I mean, this way? Further up? It's in the canvas under help session problems. Other questions? Now, listen. This is fantastic, except it is not normatized enough. What does normatized enough mean? This would be a question out of a textbook. Now Nora comes in and says, okay, so you have part A, part B. Now Nora's going to come in and say, hey, part C, part D. Here they come. So this would be added to this problem on a test. This was a test question. What we just finished would be only a piece of it. The rest of it comes in and says, hey, for the Derek problem, part C, tell me the angle between AB and AC. So in other words, hey, tell me what this angle here, theta, is. Do you know how to find an angle between two vectors?
Yes.
How? Dot product. Definition of the dot product. By the way, true or false? Here's a good one. True or false? I cannot find the angle by using the cross product.
False.
I cannot find the angle using the cross product. True or false? False, because A cross B is magnitude of A, magnitude of B, sine of the angle in between. I could rearrange it and say sine inverse of A cross B divided by magnitude of A, magnitude of B. I can do it. Do I want to do it? No, because cross products take longer than doing dot products. So the default is to go through the dot product. What do you have? You have a question? No, you didn't raise your hand? Oh, sorry. You could. All right, so remember, I already know what our AB vector is. It is 4I minus 12J plus 2K. I already know the magnitude of RAB, 12.806. I know RAC is equal to minus 4I minus 12J plus 2K. I know this is 12.806. So therefore, theta is going to be cosine inverse of RAB dotted with RAC divided by magnitude of RAB, magnitude of RAC. That's going to be minus 16 plus 144 plus 4. Divide this by 12.806 times 12.806. Theta is going to be 36.39 degrees. The 16, 44, 144, and 4, that's the i's multiplied together. The j's multiplied together give me the 144. And the k's multiplied together give me the 4. And then I divide by the magnitudes and I have the angle. Notice what? Say that again. Doesn't matter. She's asking me, can I use the forces instead of the r's? You can use anything that tells me the directional sense of the two. Yes. So your answer is yes. I can use r's. I can use f's. I can use whatever that will give me the directional sense of A, B, and C. So it doesn't matter. As long as you divide by the magnitudes of the forces. Right? You can use the forces. I'm using the R, so I'm dividing by the magnitude of the R. You use the forces, I'm going to use the magnitude of the forces. Yes. So here, what I do here, I said, let me give them a 3D problem, equilibrium, chapter 3, and now I'm like, that's not enough. That's a Hitler type problem. I'm going to normalize it. So I'm back to chapter 2, section 9, grab the angle, dumped it in. Next, it says, hey, project AC, the force AC, onto OA. Project the force AC onto OA. What did I just do here? I said, in essence, find me the component of AC onto a line OA. Right? How do I do that? Back to chapter 2, section 9 I go, and I'm going to grab the second use of the dot product, which was a projection. How do I project something? Well, I say projection of FAC onto OA. That's going to be unit vector OA dotted with FAC. You can get FAC. FAC is 1067.42 times the unit vector, which I know is minus 0.312 I minus 0.937 J plus 0.156 K. So FAC vector is minus 333.035 I minus 1000.173 J plus 166.518 K, and unit vector OA, I already know that. Why? Because I calculated it already. Did I put something in there? Unit vector OA is this right here. So it's not extra work, it's really just, hey, can you dot these two for me? It's not really extra work. it should be. This should be 0I plus 0.768J plus 0.640K. And I'm gonna dot that with minus 333.035I minus 1,000.173J plus 166.518K. When I do that, do I get an IJK or do I get a number? It's a number, negative 661.618. It is a number. Because it should be a scalar. I'm doing a dot product, I should get a scalar, a value, a number, not an IJK form. Questions? Yep. Yeah.
Question 3, the RAD over dot RAC of the maxims, will that be the same as just saying the unit vector with the dot?
I can do the unit vector. Yep. Did everybody hear what he said? Going back to this guy up here, I use the position vector. We already said you could use the force vectors, but you gotta divide by the magnitudes of the forces. He just asked, hey, could I use the unit vectors here? Yeah. Unit vector AB, unit vector AC, divide by 1, divide by 1. All I need is something that describes the directional sense of AC negative. That's all I need. So there's lots of ways to do it, not just one. All of them have to lead to 36.39 degrees. Okay? Who's not with me? Speak. I cannot read minds. I can read body language, but I can't read minds. Questions on this? All right. So like I said, if you want to make pictures of this, you are way more than welcome to do after you take the weight.